This is a demonstration of the Arduino CLI in a terminal session. When you first install the Arduino CLI, you won't have any support for any library or cores or platforms. So the first thing that we can do, we can launch the command, just a naked one, Arduino CLI, and see that we get an help screen which tells us what we can do. So for instance, we can invoke an help session for any command or any subcommand. Let's just try and clean up, and we run Arduino CLI -h. It's going to give us the same result, so the same help screen for the commands that we can run. We are interested in creating a basic sketch and compiling it and uploading to the board that we have attached. Let's first see what we can do with the board command. Arduino CLI board. We can run some commands. We can list the boards which are attached to your to our computer, and we can also see the details about a board. Let's try and run the first one. So Arduino CLI. Arduino CLI board list. It's going to run through our USB connected devices, and it's going to show us the boards that we have connected. You can clearly see that we have an Arduino Uno and an Arduino Nano 33 IoT. These boards rely on two different cores. One is an AVR, so it relies on Arduino AVR, and the other one relies on the SAMD core from Microchip. And the FQBN tells us the fully qualified board name, which is in this case Arduino AVR Uno, and in the case of the Nano 33, it's Arduino SAMD Nano 33 IoT. This command is very helpful because it's going to tell us a bunch of things about the board that we have attached. So let's first see what we can do. We said that we have no cores. Arduino CLI core list. We have no cores installed, but we need to install the two cores for the two boards that we have connected. Arduino CLI core install Arduino AVR for the Arduino Uno, and it's going to download all the cores. This is the same operation that happens in the traditional IDE, and it's installing all the tools that we need, so to upload, to compile, and everything else. Let's try and run Arduino CLI core list. We now have Arduino AVR version 1.8.2. Let's install the other one. If we don't remember, we can simply issue the command board list, and we now know that we need to install Arduino SAMD. So Arduino CLI core install Arduino SAMD. This is going to go through the same process. It's going to download the supporting files and cores and specs for every board that we created. And of course, as we can install cores that are produced by us at Arduino, we can also install third-party cores. We can see in the future how to do this. And this one is done. So our next command, Arduino CLI core list, is going to show us that we have both cores installed. Let's move forward. The first thing that we want to do, we want to create a new sketch. If we don't remember, we can simply go Arduino CLI, and it's going to show us a bunch of commands. What we want to do, we want to create a sketch. So let's try and go this way. Arduino CLI sketch. It's going to tell us what we can do. So we can clearly create a new sketch. So new will create a new sketch, and it will accept. So let's see the options that we have for new. Arduino CLI sketch new -h, and we have flags that we can give. We can give it a name, for instance. So let's just try and create a blink script. Arduino CLI sketch new blink me, and it has created a new sketch in the folder BlinkMe in our home folder. So what can we do with this? Well, let's first of all enter the path, and we have one ino file. So let's see what's inside. The sketch has been created. It's an empty sketch which contains a void setup and a void loop. So this means that we can open our favorite text editor and just go and edit the file. For convenience, I'm just going to do it in the terminal. So I'm going to edit using nano BlinkMe, and let's see what we can do here. We can set, it's a blink example, so let's just set the pin mode of the LED built-in pin to output, so we can control it. And we can digital write LED built-in high to turn it on. We wait half a second. Digital write LED built-in low. Oh, there's a typo here. And delay 500. So this is our sketch. We can exit the sketch and save it. So if we show the content of the file, we see that this is complete and it works. What else can we do with this sketch? Well, we want to just compile the sketch to see if it works, if it runs. So let's see what we have as available commands. Arduino CLI, and we can clearly see that we have compile. So Arduino CLI compile, and it's going to tell us that it doesn't know which board to compile for. Let's look at our options. CLI compile -h. It expects some flags, and there is an example which is compatible with one of the boards that we have connected. So let's just say that we compile -b is an abbreviation for fully qualified board name, and we're going to use this one for convenience. So we can run Arduino CLI compile -b Arduino AVR Uno. So if we are using, for instance, a nano, we will write Arduino AVR nano, and it expects a path to the sketch that we want to compile, but we are in the same sketch, in the same folder as the sketch we want to compile. So let's just try and do this. Arduino CLI compile -b Arduino AVR Uno, and it compiles. This is a very simple sketch, so it takes pretty much no time to compile it. But what we can do, we can see what happens in the background by simply adding a flag to the command, and this flag is V, which stands for verbose. And this is going to show what some people are interested in, to see if there's any errors, if there's any path discrepancies, and so on. So the sketch is compiled. This means that if we list the files, we are going to see an ELF file, which is for debugging, and the final .hex file. And you can see that depending on the board that you want to install, there are two options. If you upload using an ISP programmer, for instance, or an STK 500 or something, it's going to create one without the bootloader. But if we need to preserve the bootloader, it has created one with the bootloader, and this is the source file. So we now want to upload the file that we have created. So Arduino CLI, let's try upload. It's expecting a parameter from us. So Arduino CLI upload requires a flag, and it can have some flags that are related to the board we want to install to, but the one that we really care about right now is the -b flag, so the port flag. Arduino CLI board list, and we want to use this serial port, we're gonna copy and we're gonna paste it in line. So Arduino CLI upload -b Arduino AVR Uno -b, and we paste this one, and it should be uploaded. Let's just run it with a -b, and yes, it is working correctly. So our board has a blinking LED. Arduino CLI board attach -h for help. We can specify a few parameters such as the port and the fully qualified board name, but we can just more quickly specify the serial port the board is attached to, and the CLI is going to automatically recognize the board and create a configuration file that is everything it needs to quickly compile and upload. So let's see how to speed up this process. Arduino CLI board list will copy the serial port our board is attached to, and we'll run this simple command: Arduino CLI board attach serial : / and our board name, and I'm going to pass in the verbose flag so we can see what's happening. Let's clear the window and launch the command. It's doing a few things. It's recognizing the board and everything that it needs, and it's done. So if now we go list what's in our folder, we can see that we have a new file called sketch.json. What's inside this sketch.json? Let's look at it. There's a new set of settings that basically tells us that the CPU, so the board that we're connected to, attached to, has an FQBN of Arduino SAMD nano _33 IoT. The name of the board is Arduino Nano 33 IoT, and that's exactly what we have attached to our serial port. And the port it's connected to is our dev CU USB modem 145 blah blah blah. So now essentially, remember when we earlier needed to run a series of commands, right? We needed to do Arduino CLI compile -b Arduino SAMD Nano 33 IoT in this case to compile the code, right? And right now we have an attached configuration. So basically all of this can be replaced by Arduino CLI compile. Let's pass verbose through, and you see the sketch.json file tells the Arduino CLI which target to compile for. And let's look at our files. As you can see from earlier, we have the compilation files related to the AVR Uno, and we now have these two files which are related to the SAMD Nano 33 IoT. And if we want to upload a sketch, we can simply run this command. So Arduino CLI upload -v, and in a moment we should be able to see what's happening behind the scenes as it uploads to our Nano 33 IoT. Done. So our Nano 33 IoT, as you can see in the camera view, is now blinking. Half a second on, half a second off. We can even do it faster. So you know when in the traditional Java IDE we just push the upload button, we can simply issue this command: Arduino CLI compile --upload, and it's compiling and it's uploading, and it's all done, just as quickly as we saw it. I hope it's enough as an introduction to the Arduino CLI. We really look forward to giving you more content and pushing this, let's call it, progressive tutorial forward with other examples, going through other supported boards, installing extra cores, as well as debugging and building applications for IoT connected objects. Thank you.